afternoon, everybody. It's a pleasure. Welcome to these training sessions for PH4H in the 2025 edition. This is the first of several webinars. This is the first of several webinars that we're going to be having, and we're going to try to have at least 2 per month in trying to take on again the topics that many of you are acquainted with. They are part of the Conectaton projects. But today, since it's the first webinar, we have considered that it is important to refresh the ideas related to interoperability, and especially related to the interoperability standards. We're going to be looking a little bit at FHIR, but we're also going to be looking at the foundations and some of the essential parts of the different standards that we use in health interoperability. This because although many of you have participated in the Connectathon, you know that the implementations are done with FHIR, or at least most of them. It is also important to have a good understanding of the use of the other standards. So this is just to tell you that sometimes it is important to keep in mind how to use other standards in the interoperability scenarios. So today we're going to be looking at the different standards and the interoperability scenarios, and one of them will be FHIR. So please, could you confirm that you can see my screen? No problems? All right.
Perfecto. Entonces,
okay, thank you. Thank you for confirming. So why talk about the different interoperability scenarios and different standards? As I was saying, the implementations that are done with PH4H are focused on FHIR, but we also want to have, or we also want to keep in mind these other standards, which are also part of the data exchange and needs within the health context. So, what is the main problem regarding interoperability? Well, it is within the service provider, because different service providers have different information systems. It would be good if one system had everything fully integrated, but the industry itself, the health software and the specialized industry, still they have software specialized for laboratories, LIS, for images, HIS, PACS, RIS. There's a software for clinical electronic medical records. So many of you who have been in hospitals have had to integrate all of these. And there's a whole set of standards that are still applicable and very valuable. And then we need to interoperate with other institutions. When we send the reference document or the counter reference or a report, let's say the report of a biopsy, those are documents between service providers. There are other standards there that are important. So when the apps came up and when the users started using or demanding services, especially after the COVID, then other standards were also promoted. So this is the journey that we want to take, and we're going to end up with FHIR. So basically, interoperability tries to solve the following in health. We have different health information systems, and we have a communication problem. Communication between different platforms, different databases, different backends, different systems developed in different times with different infrastructure. So interoperability is one tool, it's a means that tries to solve the communication problem between informatic platforms that have a different nature. So this is within the whole health area, which will always be present. Developers who have developed equipment, apps, software applications in for their own functions or under their own business rules. And the problem is how to integrate these. So we say that it is important to work on the semantics, but also on the syntactics. Semantic has to do with the contents, the catalogs, the codes, and the syntaxes is the order, the structure. And for each of these, there are standards. And therefore, the idea is to see where fire lies and in what part is fire more versatile and what are the kind of problems that are better to be addressed by this standard. So this image was printed today. I printed it today, not to promote this meeting that will be held in Madrid in 2 or 3 more weeks, but it is the International HL7 meeting in Spain. What I really want to show you is the type of standards that are being used. HL7, what standards they promote. And we can see here version 2 standards, the CDA standards, and FIRE. So version 2, it's still alive. And it began many years ago, but it's still being used. And we'll see in which scenarios. We will also look at the CDAs, how they have contributed, where they were used very well, and what are some of the lessons learned, and why FIRE takes the concepts from CDA, which is what we're starting to do now, to use them in the medical records that are based on FIRE standards. So these are the different versions of the HL7 standards on the syntactics. Remember, syntaxis is order, format, and structure. And then this other organization, IHE, which is more based on Europe, it tests and validates the existing standards. And it uses HL7 ISO standards and also from the W3C. And they put together specification guides and they carry out connectathons. And that has also inspired us to carry out connectathons. And you might have seen that the connectathons that we have developed in the PH4H are based on IHE profiles. Here in the middle, you can see that there are standards that mention CDA, medical images, DICOM, also FIRE, and also we have version 2 and others. So the idea is to identify what FIRE can be best used for and where we should be using the other standards. Here at the bottom, you can see many different profiles to integrate biomedical equipment, ESG, AKG, or endoscopy, or also equipment for ophthalmology. So when you start looking at the different standards and messages that are used here, you can see that versions 2 is still valid. I'm saying this because when we talk about FIRE, which is the new standard, and it's a very good standard, which is helping to carry out agile, fast, and easy implementations, not always the easiest is the best. So version 2 of HL7 is a version which might be old, but rather than old, we should be using the term mature. HL7 version 2 began back in the 80s, trying to integrate admission systems at hospitals, the emergency rooms. And then also it was important for the information from emergency went up to hospitalization. So in order to do that, they invented one first message, which was the demographic data message, identification, names, gender, date of birth. That's the demographic basic information. And that gave birth to the first HL7 message back in the technologies of the 80s when internet did not exist. No networks, no XML. So the HL7 version 2 standard was defined using the technology that was available back in the days, which is just a flat files. And now we are going to look at them and we're going to see what they are good for. Those are messages. Version 2 then is messaging, basically, and we're going to see where it is used and where it could be more effective to use this kind of standard given the different scenarios. Then it evolved. Internet came up and web services, XML formats that came up, and HL7 evolved together with these new technological elements, and there it started using XML and a modeling based on the RIM model, which is object-based, and basically version 3 left a very important standard, we believe, for the industry, for the health industry, which is a CDA. Because the CDA standard, we're going to see, is the one that allowed us to model electronic clinical documents. So we're going to look at the difference between messages and documents. And then the technology continued evolving, and then the mobile devices came around, and we needed services, not only through web services or the traditional ones, WSL and contracts and all of that, but as an easier way of accessing data from other systems, which are the API REST-based systems. And FHIR, what it does is to use these new APIs REST model, and it defines an information model where what used to be messages are now translated into resources based on something that's very powerful, which is the REST technologies. Something else that's also important, and that's a difference between FHIR and the different versions, is that FHIR, as providing a service, it's also an interoperability mechanism in itself. That is to say, it also gives the possibility of exchanging data. In version 2, there wasn't a component that allowed to send out the data. And so there you needed to use a driver like Iguana, an engine like Iguana or Mir, or that the other ones that the industry was beginning to make available, including ports that read HL7, they could be resent elsewhere and interpret them. The same thing with version 3. There was no means provided by the standard itself to exchange information, and FHIR precisely provides the standard, the data models, and a server, and that gives a lot of power to the standard. So what is messaging good for? Version 2, let's say, which is still very valid around the world for everything regarding to connecting biomedical equipments, especially the ones that are points of care, that is to say, hospital infrastructure, connecting lab systems, medical images, monitoring equipment, the infusion pumps, hospital infrastructure. It's still based on version 2. Messages that are sent out to the lab, and the lab responds with one of the messages too. So these are very mature interfaces. So this is a typical case use. The medical record, a message is sent to the laboratory. It's a message that is ORM, and the lab responds with the results, ORU. So the ORM is the request, and that was the syntaxis that was defined back then. HL7 is almost 3 letters, the names, the segments, the messages. The order is requested to the lab, so the lab processes that, and then it sends out another information which is providing the results of the analysis. So we're going to be looking at this concept in FHIR that still exists. In FHIR, we do not have a message now, it's a resource now which implements the order. And there is another resource with which we can send back the result. So we changed the formats for structures, which are defined under the JSON format, which are also supported under a REST server. That was the technology that was made in the 80s when internet did not exist. The mechanism was simply flat files, and this is a message of what can be provided by biomedical devices. Every 3 or every 5 seconds, these monitors generate information which can be partial, and that can be interpreted by this format. And if you look at the top part, it's very general patient information, a segment that is called PID. The patient identifier. That's what PID stands for, and that is the patient's data. And we have another segment or other segments which talk about each parameter, which is the value and what is the result. That is the HL7 version 2. And it's very useful so that everything within this format can be used, not only the result of vital signs, but also laboratory reports of medical images and others. So here, for example, we can see the diastolic blood pressure, 90. We have the units, systolic, 120, and the units and the reference range. So what defines the standard is the segments that it has, and what field is what information in. So that's in all of the documents. When you start studying the standard, you will find the specifications there. So for biomedical equipment and for the industry, this is still quite valid because there are lots of equipments that are still working and that are connected and that are connected to infrastructure that are operating currently. So if they do not need to take the data out of the hospital, I mean, it might be innovating to use a FHIR server, but if it's just for the same functionality of sending the data from one monitoring system to the clinical medical record within the same institution, it's probably just more efficient to do that with messages. Version 2, remember, is messages. And with these 3 types of messages, the demographic data, the order message, and the results, we can solve a large amount of the interoperability needs in the hospital, not retyping patient's information, their name, date of birth, ID number, all of that data should simply flow in the hospital's application using this application, or the FHIR server can also be used. But again, as I was saying, this has been tested in order to obtain data or to interact with the medical imaging equipment. All of those technologies that use a RIS, a RIS, or a PAX, where they store the images. These type of messages are very efficient for that. Then the world changed. XML arrived, and XML provided an important solution for not only exchanging data within the institution, but also sending documents between different hospitals or health service providers. So version 3, which is HL7 CDA, the best standard is CDA, which is for modeling electronic clinical document. Clinical document architecture is what CDA stands for. And this standard allows to standardize any clinical document. And this is in order to standardize, for example, when data is sent between different institutions, documents, let's say, because these documents are now more formal and must be signed, they must be stored, and they have to be very similar to that of a physical document. So the CDA allowed to have electronic clinical documents. And when we started having them using CDA, we were able to achieve the first implementations of electronic medical records around the world. So that's why we believe that it was a very important standard, because it's the basis for the representation in XML of clinical documents. So it's a structure, or it's a standard that allows for modeling the characteristics of a document, which can be signed, which can be stored, which can be managed. And if there is an error, then an addendum is made, and there's a new document that replaces it, just as you can do when you have addendums or changes to the physical documents. So CDA version 3 documents, and documents basically are the ones that are used when you need to exchange data between different institutions. The base of this standard, which is an XML representation of the elements of a report, that is to say, a header where we have the general context, date, demographic data, doctor, the type of document that it is, and then the main body that has different elements that one may need
a un documento clínico.
For a clinical document. For example, it can have images, or it can have results of a biopsy. It could have the lab results. And that's why it's an architecture. It allows to model any type of document. So this was used in different implementations for the medical records at a national level. They can be used by sending the header and a PDF, and sending the PDF of the discharge report, the result of the 5 days of the service of someone who was in emergency, for example. And it was very helpful, precisely so that in other hospitals, they could see what the patient has previously had. And with that, a lot of the opinions can be supported. And as the data is coded, it is possible to code it, but that means that the semantics need to be put into the content, and that's the complicated part. It's not just modeling this in XML, but it needs to have the code for every single detail. Here, for example, coding from one lab, what is the code for that lab? Let's say if it's a lipidic profile, what is the code for triglycerids? How will we code that? and what is the level of detail for each of the different elements that we're going to be exchanging between different institutions if necessary. So that is why if the data is not going to be processed, a PDF might be enough, and then with that, maybe someone's life can be saved. So different types of reports can be modeled, clinical documents with the CDA standard. Experience as well. In the United States, the CCDA, President Obama with Obamacare really gave it some drive, and it is evolving. The concept to documents in FHIR, we're going to see what the equivalent of CDA is. That Spain also has important experiences with CDA. Uruguay uses CMDs, seven were right. Seven different types of documents were modified, and they were modeled in CDA, and that's why the country has more than 200 million documents and 3 million people with CDAs. In Europe, the ELGA, which is from Austria, that's their medical record from Austria, and the DMP from France. They started with the CDA in France also, and we're also going to be seeing what they're taking into FHIR. The clinical medical record of the Bogota district has been designed using CDA documents, although the exchange mechanism is FHIR. So we've arrived to FHIR. What is FHIR better for? What has it really been thought for? This standard has been considered for all the mobile data, for the apps, all the web applications also. And of course, this has been promoted, or this was reinforced with the use of REST servers on the one end, but also after the pandemic, where there was a boom on the use of these applications, monitoring, telehealth, teleconsultation, and the exchange of data by using the internet. So this is the best scenario for FHIR if we have the need to take the data between different places, and we need to monitor not the patient within the institution, but my specialists, let's say, are elsewhere in a different city, in a different department, or even in a different country. If the mechanism is internet, then most likely FHIR is an interesting alternative. If the data needs to be seen within my own institution, well, version 2 is still useful for that. And that's why I would say that not everything needs to be changed into FHIR. It depends on what it's going to be used for. If we need, we can use a screwdriver as a hammer, but the screwdriver has to be designed for screws. The same thing with standards. We can use FHIR for exchanging information within one institution. Sure, we can, but we can see that not all the resources are as mature as they are in version 2, and maybe we might not have all the defined implementation guides in order to carry out those implementations. So, what is the paradigm behind FHIR? Resources. Version 2, remember, messages. Version 3, CDAs, documents. And here it's resources. Resources using REST services. And this all is built on an interface mechanisms, which are the APIs. So which is the API in order to have access to these contents in the FHIR server. So the recommendation is resources. Remember, FHIR, resources. We need to identify the domain, the problem, and to see which resources are associated to that problem. So here, just very briefly, let me try to
los recursos Fire, ¿no? Entonces,
Let me try to show you the fire
ahí,
resources.
creo que está ahí. Luego colocamos cuál es la página de Fire.
We will share the fire's page or site later on.
Bueno, otra cosa que cambió mucho también en el estándar
Something else that changed
fue
quite a lot in the
esta,
standard.
exacto. Muchísimas gracias, Lucía.
Thank you, Lucia, for that. That
Sí.
is what I was looking for.
Ese es el sitio de donde se encuentran los recursos
That's the site where
de
you will
Fire.
find the fire
Y entonces
resources.
vamos a ver qué es
So let us
lo
see
primero que hay que recorrer dentro de los recursos de Fire.
what
¿Ya?
you have to do once you have the resources in fire.
Exacto. Una cosa que cambió y que es
One
interesante
thing
también
that changed,
de
which is
Fire,
also
es que
interesting about fire,
antes había que
is that in the past,
afiliarse,
you
tener unos
needed
permisos
to
para el uso
subscribe,
del
you needed
estándar
to
y
have
ahora
the
está
permits in order
libre.
to use the standard, and now it's an
Obviamente,
open
los
standard.
capítulos
Now,
nacionales
obviously, the
siguen
national
existiendo
chapters
y
still
lo que hacen
exist,
básicamente son
and basically
tareas
what
de
they do
capacitación,
is training,
promoción de afiliamientos y
promoting
demás.
the
O sea, los capítulos
profiles,
nacionales
that is to say,
cada
the
vez
national
anteriormente,
chapters.
si uno estaba
In the
afiliado,
past,
podía usar el
could
estándar
only use the
realmente.
standard if they were
Ahora hay
subscribed.
un uso libre
And now
y
there's
los
a
capítulos
open
nacionales
free
siguen
use, and the
teniendo
national
un
chapters still
espacio
have
importante
room, an
en los
important
temas de
space
entrenamiento,
in
capacitación y divulgación de recursos.
training
Entonces,
and learning how to use the
siempre que estamos
standard.
acá, como le
So
decía,
when
lo
we're
más
here,
interesante,
the
lo que
most
hay que, por
interesting
donde hay
thing,
que
or
entrar en el estándar,
where you really need to
diría es
start with the
conociendo los
standard,
recursos.
is
¿Ya?
by learning
Entonces,
about the different
brevemente
resources.
solamente
So
decirles que
very briefly,
existen diferentes tipos de
there
recursos
are different
fundacionales,
types of
recursos base, los
base
clínicos, los
resources, the
financieros
clinical
y los
resources, financial
especializados. ¿Ya?
resources, and specialized
Generalmente
resources.
uno
Now, normally,
especializa o empieza con ese grupo de
we
recursos.
start
Uno de los
with
recursos
the
más
different
importantes
types
y
of
que
resources,
recomiendo
but one of the most important
recorrer
ones that I
es el
recommend that
recurso
you go through
patient, ¿ya?
is
Porque el patient
patient,
tiene
because a
los datos de la
patient
persona.
is the
¿Ya? Y
one that
recuerden
has
que ahí están los
the
datos
patient's or the
demográficos,
person's
pronombres,
data,
apellidos,
demographic, name and
exactamente.
surname, date of
Otra
birth,
cosa
and
que es
other
importante y
information.
que también diferencia
Something else
este
that's
estándar
important and which
de
also
los anteriores,
makes a
porque este es
difference
un
between
estándar en
this standard and
evolución, un
the
sistema de
other one,
recursos
remember that this
de
one is still
balotaje,
in
que es
evolution. There are still
donde los
ballotage
expertos
process.
dicen
That is to
ya
say,
este recurso está
experts get
maduro.
together and they say,
Entonces,
this
uno
resource is
mira
mature
qué tan
enough.
maduro es un
So we can
recurso
see how
y
mature a
cuando ya son más
resource
maduros,
is,
los recursos
and
tienen una
once
N,
they are fully mature,
estandarizados y ya
they have been standardized, they have
cumplieron todo
this
un
N
proceso
next
de
to it.
balotaje,
They have gone
¿ya?
through the whole
Dentro
assessment
de la comunidad
process
HL7.
within the
Entonces, esto que quiere
HL7
decir que, por ejemplo,
community.
miren, acá
And this
en
means that,
seguridad,
for
en este
example,
grupo de
here on
recursos de seguridad hay un
security,
recurso que se llama
we have
permission
one called
y tiene un
permission,
nivel 0.
and it has level
Entonces,
0.
meterse a hacer algo con ese
So
recurso,
trying to do something with
podemos
that
hacerlo,
resource, I
pero lo
mean,
más seguro
sure,
lo
we
que es que
can,
vayan a cambiar
but
en los
most
futuros
likely
procesos
it will change
balotaje, ¿ya? Entonces,
in these ballotage or
la
assessment
recomendación es esa.
processes that I
Básicamente
have just
tratar de
mentioned. So the
utilizar
recommendation is to
recursos
try
que
and use
tengan un
those
4, 5 o
resources
un
that
N.
have
O sea,
level
ya
4,
los que
level
han
5,
pasado
or
el
an
nivel
N
3
next to
ya
it.
tienen procesos
After level
importantes de
3, they have
madurez. Por
important
ejemplo,
maturity
este
levels.
recurso
For
paciente,
example, here, patient,
en el cual está la información que
we have
permite
the information
básicamente
that
gestionar
allows us
los datos
to
de las
manage
personas, de los
the
pacientes, ¿no?
patients or the
Y
person's
para entender un
data.
poco lo
And
que
in order to better
presenta el estándar,
understand what the
básicamente
standard
los
gives
elementos
is
para cada recurso.
all the elements
Sí,
for
el
each
nombre de la
resource.
tabla y los
It's like the
campos, ¿ya?
name of the
Entonces,
table and the
este
different
es el
fields.
recurso,
So this is the
y estos son sus
resource,
distintos elementos,
and these
que
are
son
the
como
different
los campos.
elements. These are the
Por cada
fields, so as to
elemento
speak.
hay
And
una
for each element,
especificación. Miren,
there's a
miren esto que es como
specification. You can
ruido, quiere
see
decir
this
que es
one has like a
nivel
cube, which means that there are fields that are composed, and there are others that are single or simple fields. So if it's compounded, then it means that it's made up of other values, and if it's only single value, it's either a yes or no, one single data, no additional metadata associated to it. So for example, identifier, you can see that it's got a cube. Therefore, it means that this is a field that has other fields in order to define it. For example, address. Identifier. There. So the field identifier has all of these fields that define it. That is to say, it's a field with a subfield. They use the type, the system, the value, the period, the assigner. So when you start looking at the standard, you have to see at each of these elements. And it's interesting because what really helps you to learn is what are the best practices in order to model an identifier. So we can see here that an identifier, in order for it to be well modeled, is not just the type of identifier. In order to model an identifier, you would need a type, let's say ID number, and the type and the number. That's not enough. I mean, it's useful, but in order for it to be interoperable and within an ecosystem between different countries, there's a recommendation, right? Which is additional metadata so that they can identify who created that identifier, so that in an interoperability process, we can say this is a unique identifier. 6767 before Olivia is different to 60 from Bolivia, let's say, is different to the 6767 from Colombia. So it's got a prefix. It's going to say this one was assignated from Bolivia, this one was assigned from Colombia, from different places. So this is a data structure in FHIR which brings everything that was modeled in version 2. This is modeled in FHIR, but it brings about all the knowledge that was developed since the 80s. And there were some things that were removed because FHIR cleans up many of the fields that weren't needed, and only the most specific set of data that is needed are the ones that are used in order for it to be accurate. So the name. Let's take a look at address. Address is another field which is also made up of other subfields. So you can see here all of the different variables that we have to keep in mind when we're going to define address. So this is all demographic data. And then what the countries or what the ecosystems start doing is what has been called profiling. Profiling is localizing, locating the standard according to our governance level. In this case, countries. Countries decide, for example, that they're going to use the first and the second surname. If they might have different specifications for gender, will they call it gender? Will they call it sex? So the standard can also be localized according to the ecosystem in which it is implemented. And that is why the implementation guides have been put together. Other elements that are also important is to identify within the standard. You can see some flags here, which basically tell you the level of summary. if all the summaries are there or not, cardinality, whether it's 0 or 1, most of them are 0, 1, because it's either has to be or has got to be there, or is it mandatory or not mandatory. But if it is needed for it to be mandatory in my ecosystem, then I can profile it, I can choose it, and I can turn it into mandatory. So within my organization or within my country, we can make such and such field mandatory or not. And there are other fields here, like this one here. This is a Boolean. It's 0 or 1. Boolean is yes or no. There are other fields like deceased. It could be both, yes or no, but also the disease date and time. So the recommendation number one is to go through the different resources, because that's how you really learn FHIR, by going through the resources. An important resource is just to make a reference to version 2. Version 2, remember, was a message that brought the results, and there's a resource in FHIR that brings the results, and here it is called observation. Remember, the patient was PAT, and then ORM is the request, and the result is ORM. So results are not ORU, it's now called observations. It's in English, but it's a lot more understandable. It's very versatile, and it's the resource that is used for all the monitoring systems that provide data like vital signs, laboratory images, and the like. So if we need not only to monitor the data, but we need to keep them in our institution, we need a message that is being sent through the internet. This observation resource has the metadata where one can put the parameter code that will be sent out. It has an identifier, who created the resource, the context also. But here there's something that's very interesting, which is the semantic side of it. It says the code, it's the code for the result. So they could be LOINC codes. That is, they're saying you send out the results coded, and this is the semantics, the subject, for what person, what time. And here you can say, or if you're going to send the glycemia, that's one level. Or if you send out the result of a test in the Boolean format, if it's COVID, for example, yes or no, different types of possible values for the different types of results. So patients, results, etc., etc. So I think that this is key in order to understand FHIR, surfing through the different resources. Medical orders, for example, for a pharmacy process, for an electronic prescription, medication request, that's the prescription, the electronic prescription. And this resource has the metadata in order to put together a prescription. And here we have all the medications, the dispensing of the medication. We have requested 4, for example, 3 have been delivered, and the different fields are used in order to put together the packaging, etc. But the most complicated thing is when you go into all of these resources, there's always some codes, some values that say medical code, packaging unit, dosage code. And I'm saying this because when we find the format, then we are going to look at the syntaxes, and we're going to have to solve the problem of the whole semantics. So for the semantics, I want us to see in these last few minutes the rest of the presentation. Because having seen this, what FIRE has then is a definition of resources, parameters or resources. It has a server that behaves or that works with the CRUD, with the API REST, create, post, read, get, update, put, and delete to a server URL, the resource information. And then in real life, not only do you send out just one single resource, it's sent out in a package, and that's what's called a bundle. And there are bundles for documents, for operations, and this is how operations are carried out in FIRE by sending bundles out to a server, which can be implemented. There's a free open source software that implements the standard, or there are some off the shelf too. For example, HappyFire is open, and then we have Azure, Google, Oracle. They are off the shelf, and there are many different companies that are providing ports that also read FIRE-based standards resources. So the applications can interact by sending and reading, or having a facade, which is that nothing is stored in the server, but all the server is only useful for the transformation so that it can be interpreted in the FIRE service. So just 5 minutes for the semantics. Because after having solved the structure, we cannot forget the semantics. We need to come to agreements on the contents that are going to be sent. So we often believe that this is the easiest, and it's actually not that easy. So a simple variable, demographic variable, which everywhere where we go, I mean, it's not always easy to find a consensus. Is it sex? Is it gender? Is there identity? I mean, just naming it is a problem in itself. How are we going to call it? So in HL7, for example, sex is gender, and HL7 codes it as male, female, and other. So that cannot be changed. So if you code the gender in HL7, it has these values, male, female, other, that are required. These cannot be changed. ISO standard, if you remember that IHL7 is an ISO standard. It has 0, 1, 2, or 9. 0 is not known, 1 is male, 2 is female, 9 not applicable. So two standard organization. HL7 is an ISO standard. And look at the ISO standard. And H or M. H could be hombre or hembra in Spanish. So it could be, these are all semantic problems. And just one very simple variable, one single field. So what about when our health professionals, when the practitioners are thinking about this? IAM. Is it a myocardial acute infarction, but it could have a different meaning to HTA, and QX could be surgery. That is to say, variables can be interpreted differently. So like oxygen saturation, for example, how can we unify then the different identifiers for the contents? So this is for vital signs, for different parts of the body, for medications, for the genome sequences, lots of information that requires semantics in terms of the clinical medical records. A simple parameter, vital signs, for example, it could be a tree of information which has different parameters, but for example, blood pressure has sub information under it, right? If I say, give me the vital signs, that's a whole set of parameters, but there are a set of parameters that have a subgroup. So we need to have the specific special coding for each of them so that we can model these structures that have a different taxonomies. And that's an important space for SNOMED and LOINC. These have codes. In the case of SNOMED, more than 500,000 with 19 different hierarchies where you can find different codes for different parts, as we have seen here. And LOINC has codes for laboratory, medical images, types of documents. That's it, basically, I think. Well, I believe that we have run out of time. These are just examples of LOINC. These are parameters that can be used either in version 2 CDA or FHIR. They will require to have this information that is clear of blood pressure, whether it's systolic or diastolic, and what is the value for that parameter. So the message is basically, sure, we can have the structure, we have the syntaxes, but the contents and the meanings are equally important. And these are the challenges that we're going to continue facing when putting together the PH4H. I want to close by telling you that one of the standards that is coming is the IPS. IPS already has contents, already has specifications, and we are identifying some semantic elements for the region, like allergies and medications, so that they can be interpreted by the applications that may be used by the different healthcare providers or services in the region. There's a lot more that can be shared, but as an introduction, we believe that this is good to have a general overview of the different HL7 versions, the ones that are still valid, and where FHIR can be the most important standard, and never forgetting the semantic coding, because that's what defines the element that we're going to exchange. On next week, on the 30th, we're going to go into the IPS standard, why it is used, and to better understand the structures on how that standard is made up. And thank you so very much. And if there are any questions or concerns, we still have maybe a couple of minutes. If anybody wants to ask any questions.
Fernando, ¿tenés uno en el chat? Que dice
yes,
que
there's one question in the chat box, yes.
¿Se puede hacer conversión de V2 a FHIR?
It can be, if there can be a conversion from V2 to FHIR. And the answer is a yes. When we look at the FHIR resources, almost 80% of the elements already existed in version 2. That is to say, we can map from version 2 to FHIR. My recommendation would be, if you're going to do that, that's because you're going to be using it in a web application. If it's within the same institution, message is more than enough. There's no conversion needed. I mean, we will be using FHIR just for the sake of it. But no, let's use it to really take advantage of it. In fact, in some resources, it might not even be necessary. We have to be careful. So FHIR, for example, has, or each FHIR release, they're currently in release 5. Each release has changes in the resources. The ones that do not change are the ones that have that N next to it. So if you use resources in FHIR, use them that have level 4 or higher up, because when the release changes, there will be fewer changes there. And there are certain compatibility management that is required in certain cases. But medications, for example, there were very, very big changes there. So you can start with a project with the electronic prescriptions and the medication resources, if their level is 1 or 2, is highly risky. So you might say, well, HL7 version 2 would be better for that. At least for that case, for example, the model's a lot more stable. And obviously you can take that model and you can turn it into a resource of your own.
Bien, ¿contestaste la segunda pregunta? Si se podía presentar las
Have you
versiones.
answered the second question also? Yes, I have.
Sí, claro.
Yes, the answer to the question is a yes. Because the patient resource, the resource patient, remember, it can be human or it can be an animal. Yes, of course. You're thinking about One Health. Yes, the resource patient, it could be a human or it could be a human. It also has laboratory results.
Sí, se puede hacerlo en Fire. Mi recomendación es utilizar
My
recursos
recommendation is to use mature resources, but it can be done in Fire. And making sure there are biomedical equipment like all of the biomedical technology is still based on version 2. So if you're going to use the information of these biomedical equipments within the institution, you're going to have fewer difficulties by using version 2 because the same suppliers, the same developers of that infrastructure give you those kind of results. And there are gateways that give this kind of messages, that provide these kind of messages. Very well then. We are ready. Time is up. Thank you so much for those questions also. And let us continue learning in the coming sessions. As I was saying, this is just a first introductory session, and we will be including more topics related to standards, mobility, security, and of course, we're going to be looking at a Fire more structured seminar that will allow us to have more practical processes. I will see you on the 30th. Thank you so much. Goodbye.